Alright guys, welcome back to another video. We're going to talk about angles today, okay, and pretty much the basics of them with a couple of geometry terms mixed in that you might have heard before. It depends on what your math background is, okay. So we're just going to jump right into it. Here we go. Okay, good application, but I don't know if you've ever seen these before, miter joints, okay. Miter joint is just pretty much two pieces of wood being cut to make an intersection so they kind of like fit into each other like this. So these ones have 90-degree angles to them, okay? Sometimes, depending on the joint, they can actually lock into place, which is pretty cool. So if you work with your hands a little bit, if you do woodworking, miter joints are a great example of where angles are important, especially when it comes to building items, okay? All right, first definition. And I'm going to tell you right now a lot of definitions in this. So if you want to print the PowerPoint slides and just fill in the blanks, I'll provide that on my Google Classroom. But array is part of a line, starts at an endpoint, and extends infinitely in one direction. So we're not looking at the full line, which goes left and right. This only goes, well, one. Either left or right, okay? Or north or south, depending on where you're pointing these things at. But so right here is my starting point, M, and it's going to go infinitely in this direction, in the direction of O and P, those 2 points. Now, when we name these things, okay, we have a new symbol. It's kind of hard to see there, okay? So it's going to be half a line symbol. Okay, that's a ray symbol right there, okay? So it's half a line. Order matters. Okay, so I'm going to write that. Order matters. That's important. It's always the start point that you list first. Okay, so for instance, if you look at all of these naming options, M is always the first one because that's what we start with. Then we could pick any other point on the line that's after it. So I could use O, P, or whatever's after point P. Okay, but that's important. I can't reverse it, unlike a line and a line segment that I could. Opposite rays. Another way to say it, it's a line. It really is. But it's another way to describe a line, okay? So two rays that have a common endpoint and form a line. So here I could say that ray JH and ray JK are opposite rays. They both are here at J as their starting point, and they're going in opposite directions, okay? So kind of a weird one, but like I said, it's just using a different object to create another object, which would be a line. Now an angle, well, we know what an angle is, but in math terms, how do we describe it? Well, it's a figure formed by two rays with a common endpoint. Okay? So take a look at this picture here at the bottom. X is the common endpoint. I have ray XY and ray XZ there for me. Okay? Now, that common endpoint does have a name. We call it a vertex. Okay? And that vertex can also have a number associated with it if you'd like. Okay? But that's the common endpoint where two rays are formed. Okay? So how do we name angles? There's a couple ways of doing it. It just depends on the information. I'll tell you my preferred way after this. One, by its vertex. So if they both meet, if both rays meet at angle B, you can call it angle B. Okay? Or both meet at point B, call it angle B, sorry. Two, by a point on each ray and a vertex. So you could call it ABC. And let me just expand upon that a little bit here. Okay? If that was my angle, I could call it angle B. That's what the first one says. Now angle ABC, I named it with 3 points here. Notice something. The vertex is always in the middle when I name it. So since B is in the middle, it's going to be in the middle when I name it. A and B are on the outside. Okay? Now I could flip this. I could say CBA. These mean the same thing. I'm just going in this direction instead of what? That would be what? Clockwise. So this would be counterclockwise. So whichever direction you go with, the vertex has to be in the middle. Okay? I prefer this method. reason why I prefer it, what happens when we start doing this and we start branching out and we have more angles to deal with? It's going to be hard. You can't just say angle B because there's a lot of angle B's there, right? So using 3 points, you're being more specific to the region. If I said ABC, well, looking at this whole entire, if I look at this whole entire thing, well, this is good because I'm looking at the whole angle, ABC. If I want to look at ABD, I know I'm only looking at that angle there. Does that make sense? If I want to look at ABE, that whole angle, then that's how I'll write it. So that means this is what I'm looking at. So the 3 letters, I think, does a great job at showing what specific part of the diagram you're looking at. And lastly, you can name it by the angle. So if we go back to the last slide real quick, I had angle 3 down there, so you can also use the number. Okay? A lot of ways of naming angles. It just depends on the information given to you. I would say start naming it with 3 letters and get comfortable naming it with 3 letters as soon as possible. Okay? Because it's going to be needed in future lessons. Example. Name 3 rays in the diagram and 3 angles in the diagram. Okay, so I'm going to write this here. So name 3 rays. Well, we can have ray SP, right? That's half a line. We can name ray SQ and ray SR. Okay. Notice S has to be first because that's the starting point for each one of those rays. Second one. Name 3 angles in the diagram. Okay, well, we could say angle 1, angle 2. Can't write. Angle 2. We could use those. You could say angle S, which is the whole thing, right? I'm going to write beneath. So angle 1, I can name a little differently. I can name it angle PSQ. I would write that down. That's pretty important. So angle 1 is just this guy, but I can also name it PSQ because these 3 points represent that space. Angle 2 I can write as angle QSR because these 3 points identify this space. I could have named it RSQ in the reverse direction. Okay, so 3 ways of naming it, all kind of listed here. Last question. Can PSQ be referred to as angle S? No, it can't. Angle S is everything here in this picture, right? PSQ is just this part of the angle. It's not the whole thing. So if you're trying to state something more specific, you have to use the 3 points. Angle measurement. Angles are going to be measured in degrees in this class. And 1 degree is 1/60 or 1 out of 360 of a degree of a circle. Okay? Why did I mention that? Well, there's another way to measure angles. It's called radians. Okay? Look at angles from within a circle. Okay? If you look at these 2 angles, or I'm sorry, if you look at this angle right here, I could say how many radii, how many radiuses can I fit inside of the space. So I could measure by radians. And that's something for more of a trig class or your pre-calc classes. And geometry, we're just going to deal with degrees, so you don't have to worry about it. One thing to note, depending on what calculator you use, because I don't know what you're using at home, if you use a graphing calculator, okay, if you go onto the mode button right here, you should see what's highlighted there. I don't know if I'm too close or not, okay? Mine says radian is highlighted, so I'd flip over to degree to make sure my calculator is measuring it in degrees, okay? If you have a scientific calculator, you'll see DEG usually at the very bottom of the screen. If it says RAD, then you got to change it to degrees, okay? So just a small little calculator lesson for you, because if not, when you get the trig and you start doing trig functions, your measurements are going to be way off. Okay. Types of angles. This should sound familiar. An acute angle is less than 90. And these are all adjectives. That's all it is. A right angle has 90 degrees exactly. It also is represented by that square. Anytime you see that square or box, it indicates that that's a 90-degree angle. Obtuse is bigger than 90, but less than 180. A straight angle is exactly 180 degrees. A reflex angle is greater than 180. Okay. We really won't be dealing with reflex angles. We won't really use that terminology in here that much. Okay. We're not going to really measure angles bigger than 180 degrees. At least not yet. Not for this intro. And the last one, full rotation is 360 degrees, which is a circle. Okay. All right. Next up, classify the following. Now, I am trying to get this video as small as possible. Okay. So make sure you're pausing it and you're writing this down. Let's see. Angle PML, angle LMO, and angle NMO. Okay? We're going to classify. So you know what? No equal signs. We'll put one dash. I'm not talking about a measurement. Okay, PML, I think that's this guy. PML, that's this space. It has a box, so this is a right angle, because it's 90 degrees. Next, from L to M to O. So I'm looking at this entire angle space here. And inside of it's 90 degrees already, and we're going past 90. So not knowing the exact measurement, but if it's going past 90 degrees, it must be obtuse. And lastly, from angle N, M to O, that's this space right here, we can use the other angle as a reference. If 90 looks like this, that's not reaching 90. It's going to be less than that, so it's going to be an acute angle. Okay? Not bad considering that, we're just doing this based off of really one measurement, the 90-degree angle measurement. Okay, angle addition postulate. We did this with line segments, if you remember. Okay, so what this states, angle B, this whole thing, A, B, and C, this whole entire thing is equal to this angle plus this angle added up, which is pretty intuitive, okay? But we have a way of writing it. So notice I wrote down the two angles. So ABD, this guy, DBC, DBC, this guy. If I add them up, I get the entire angle ABC. Now, also, one little thing to mention. See how there's an M here? So M stands for measure, okay? If you don't have the M next to the angle, then you're just using it to describe, well, characteristics of it, right? Is it obtuse? Is it acute? Can it be congruent to another angle? Okay. But if you're talking about measure, degrees, or anything like that, put the M there. Okay. All right. So to try an example out. I think labeling the picture is a good idea. Mine's not going to be drawn to scale what I'm doing right now. Okay. Not going to worry too much about that. So let's use the information. We're going to put it on here. We're going to write the equation like we did with the segment addition postulate, just to get used to writing in mathematics, and then we'll solve it. So the measurement of RST is 22 degrees. TSU is 69 degrees. They want to know the measurement of RS and U. So this whole thing, what's the measurement? That looks like a 7. That does not look like a question mark. That looks like a question mark. Okay? Now, thinking about this, without even really writing this out, figure out the whole angle, I'm just going to add these two, right? The 22 and the 69 degrees. Add them up, and I'll get my answer. Which should be what? 91 degrees? It's slightly bigger than 90. So how do I write this using the proper symbols and notations? Well, the measurement of angle RSU, which is the whole angle, is made up of the smaller angles, which is RST and TSU. So once again, this is the whole angle, and these are the parts of the whole angle. Okay? So just do some substitution. I don't know what the whole angle measurement is. RST is 22 degrees. This guy is 69 degrees. So to finish it up, if I add them up, I get 91 degrees. Okay? Classify the angle. This would be obtuse. Okay? Not by much, by 1 degree, but it is obtuse. Okay? Once again, can you do this without writing out an equation and substituting? Absolutely. It's just getting you used to writing things using math symbols and math notation and different things like that. Okay, so the calculation, not bad. This part takes a little bit of practice, that's all. Okay, try one more. So the measurement of MPQ is 162 degrees. So this time, I got some space here, so I'm gonna, why not? It's Q, P, N, M. Okay. So the whole thing is 162 degrees. NQP, 52 degrees. And I want to know what this guy is. MQN. Okay. How do we figure it out? Well, these two add up to be 162. I know one of them. So to get the other guy, I got to do a little bit of subtraction, right? So this is going to be, well, I think it's, 110 degrees, right? Something like that. And yeah, it's not drawing to scale, guys. It's just a picture to help us put stuff in place. So let's just, once again, let's just practice this. We know what the answer is already. So the measurement of MQP, which is the whole thing, is made up of the smaller angles, or just the angles inside of it, not necessarily smaller, which is this. Those guys. Go. Do some substitution. This is 162 degrees. I don't know this guy. I know the other guy, 52 degrees. And to solve, we subtract 52 to the other side, so we get 110. So this is another obtuse angle. Okay. Not bad. Takes practice. I feel like I repeat myself a little too much, and I apologize. All right, a couple other things to wrap it up. And I'm doing pretty good on time. Congruent angles. If two angles are the same size and the same shape, then their measurements must be. That's something that we can connect with, right? Okay. If you hear the word bisect, it's a figure that's divided into two congruent parts. So bisect is cutting something in half. And an angle bisector is just more specific. You're cutting an angle in half. And that angle bisector is usually a ray. It's half a line that cuts that angle in half. Okay? So, here's an example of an angle bisector. So here's my entire angle, x, y, z. YW is the ray. It's going to cut it in half. Then we have 80 degrees and 80 degrees. Okay? Now, if angles are congruent, they're going to be measured with arcs, congruent arcs. See how this angle and this angle both have an arc inside of it? They're congruent. Now, I know over here I put an arc to represent the outside. You could put it around the other side. That's just how I label things, and that's going to vary on how you do it. Okay. So down here is the written of what's going on here. Angle XWY is congruent to angle ZYW because ray YW bisected the angle. Okay. All right, I got 2 more examples, guys. Hang in there. This won't take too much longer. To be honest with you, I don't have much time. I got a class coming up. Okay. So I'm going to go ahead and find a new marker because that's dead. Didn't know I was going to rhyme there, did you? There's W, Y, Z, U, V, and X. Ooh, a lot there. These guys have arcs. Okay. W, XY is 15 degrees. XY is going to bisect this whole angle, okay? And UXV, this guy is 40 degrees. Find YXU. Let me get another color. Make this look pretty. Y, X, U. Okay. So let's figure this out. We're just going to draw in the picture for right now. Okay. I need to know what these 2 angles are because that's what makes up the green angle. Okay. This guy bisects this whole angle. So if that's 15, this is 15 degrees. The problem states that. Now down here, these are congruent arcs. So this angle and this angle are the same measurement. So if that's 40, this guy is 40 degrees. So far so good? So that means the measurement of YXU is going to be the 15 degrees plus 40 degrees. So to wrap it up, this will be 55 degrees. So that's what, acute? It's going to be an acute angle for that guy. Okay. See how I broke it up though? And sometimes it helps to retrace things. But this green is outlining the angle that's in question. And then I used the arcs to know what this angle was. This was a bisector that cut this whole angle in half. So if that's 15, that's 15. Because remember, bisect means it cuts it into 2 congruent parts. Okay? Oh, no. Sorry about that. Okay, last problem. It's like the same picture, really. Oh, well. I got like 7 minutes to do this with you guys. Am I going to complete my mission in time? I hope so. The pressure is on. Especially when I write something down wrong. Okay. And this is honestly the same setup. It's just getting you used to hearing and seeing the notations. So ABC is 44 degrees. BC bisects ABD. The measure of EBF right here is 23 degrees. CBE is what I'm trying to figure out. So that green angle. And pause the video and try it out yourself. So here's my congruent arcs. So if that's 23, this is 23. The person told me that ahead of time. They drew something to let me know. BC, this ray is bisecting this angle. So if that's 44, this is 44 degrees. Now I'm just going to add those 2 up, and I'm done. So the measurement of angle CBE is equal to 44 degrees plus the 23 degrees. So the measurement of this guy would be what, 67 degrees? I'm done adding. Another acute angle. We could add that last little step. Okay, it's acute angle. Okay. That's just working with bisect. That's it, guys. Okay, that's angles. A lot of information crammed into the video, but shouldn't be too difficult to decipher. But if you have questions, let me know. That's no problem whatsoever. Okay, I'm here to help you guys. So stay tuned for the next lesson video. Until then, have a good day, guys. Enjoy it.